Hello, this is the presentation for the course of project of EEL6825 pattern recognition. And my project title is face recognition using principal component analysis. And the presentation will contain 3 parts. Part 1, principal component analysis introduction. Part 2, PC application, face recognition, and program development. And part 3 is program test and results. Okay, first part 1. Principal component analysis, or PCA, is actually an algorithm, basically an important statistical method. It's a method for identifying patterns in data and explaining the data, which can highlight the similarities and differences. And most important that it can help to keep the important information and then reduce the larger dimensionality. So usually the data set will contain lots of dimensions. I will use the 2D program as an example, since the 2D program can usually be brought to a figure. Here is the original data set of the blue circle points. Then the first step is usually to try to make the mean value of the dimension to be 0. Actually, this step is simply move all the data to the center of the coordinate without influence in the relationship of these states. The next will calculate the eigenvalues and eigenvectors of the covariance matrix. Then I will plot it. Then we find out that these 2 red lines actually the eigenvectors. We find that around this direction the value is a lot, and around that direction the value didn't change much. So next we can talk about the principal components. Actually, these eigenvectors are all considered as components, and then the components with large eigenvalues, every eigenvector is according to an eigenvalue, so those components with large eigenvalues usually contain more information, which also means they are more significant. Then the principal components are usually the eigenvectors with the largest eigenvalues, or it also could be a group of eigenvectors. So these eigenvectors, or say principal components, are all needed to be remained. Okay, after that we try to transform our original data to a new data set. In new data set, the eigenvectors will be the coordinate axes. Just like this figure, we find that along x direction not much change in the data, but along y direction there are a lot of changes. Most of information are along the y direction. Okay, then it's part 2. Part 2 is about PCA application in face recognition and the development of my program. We all know that an imager. We are only talking about a grayscale imager here. If it's colorful, we'll transfer to a grayscale imager, and an imager could have m multiply n dates, and we can simply express every imager to a m multiply n vector. Then we have a m multiply n dimensional vector. So if we choose a large group of images, then put all these vectors together, we build a matrix. Then we'll consider this as the original data for our PCA method. After the PCA method, every vector of the image are actually transformed. Then we'll find a testing image. So test image will also do the same transformation. Then we need to find out actually the first group of image is actually called the training image. We need to find out which training image is actually according to the testing image. So how can we calculate that? We use the most easiest way, the OG leader distance. basically just calculate their square roots. So next I will talk about the program development. I write my program in MATLAB, and the AT&T phase image database is used for program development and all the tests. Simply, I have two programs. The first one, I only test one testing imager, but usually one imager cannot really show the performance. So I write another program which I can test a series of different testing images. Usually the first step is just like we said about, we need to set the database of both training date and testing date. Then we need to do the PCA method and get the features. Finally, we find the result by calculating the distance. The only difference between these two control block is that on just one we can find that we have a loop, so we can change the database every time and let the program do testing automatically. Okay, then comes to the part 3. I'll show the program test and the result. First, we find this is the test image I choose. Actually, it's the 8th image of subject 24, and we can find the result. It tells us it's the confidence image is T24, which means training 24 is actually the first image of subject 24. So we know that they belong to the same subject, and obviously, if we simply look at these two photos, we will also know that the program gives the right answer. But it's usually, single test usually not so perceivable. So I do a whole test. That's why I write that automatic program. And since the AT&T phase base has 40 subjects, each subject has 10 photos. So I choose all the other 360 photos as the testing images, except those 40 training images. While the result seems not so satisfied, the accuracy rate is only 62.2%. So seems that maybe because the PC method is actually a quite basic one. So when it has a large training data, it may be hard for the program to get a higher accuracy rate. Okay, finally I'll do the program demo. So here we have testing images, we have training images, we have MATLAB. This is my program. Since it's on my laptop, I already have typed all the paste I need and the name of the testing images. So I just can simply click run. Okay, we got the result. This is the test imager as I showed in the PPT. And this is the content imager. We can see that the program works right. Okay, so this is the end of my presentation. Thanks.